This presentation is on electromyography and muscle contraction type. Electromyography, or EMGs, measure muscle recruitment activity. EMGs can be used by PTs to inform the clinicians how muscles are working and to help them make decisions about various exercises. Different contraction types require different amounts of muscle recruitment. This difference depends on many factors, including gravity and CNS activation. The purpose of this study was to examine muscle recruitment during different muscle contraction types. We did this via EMGs. During eccentric contractions, we expected that there would be less muscle recruitment than during concentric contractions because during eccentric contractions, the muscles do not have to overcome the force from gravity. In this particular experiment, we had 8 participants. They were all recruited from the DPT class of 2021 during biomechanics lab. They were 22 to 30 years of age, and there were 3 males and 5 females. First, the participants had to resist against the researcher to find their wrist extensors and flexors. At that point, the part of the skin where these were found was shaved and alcohol swabbed to ensure good conductivity with the electrodes. Then the electrodes were stuck on both the extensors and the flexors of the participant, and with 2 other leads as grounds attached to the biceps and the triceps. We then had the participant contract against resistance again to confirm that these electrodes were in fact placed where anticipated. Then, to obtain peak EMG, we had the participant maximally contract their wrist in both flexion and extension. These values were used to compare the rest of the data too. The participant was seated with their elbow at 90 degrees and their hand off the table, and they performed isometric wrist extension and flexion, concentric wrist extension and flexion, and eccentric wrist extension and flexion with a 1 pound weight in hand. After all results were obtained, descriptive statistics were done on this data to find both the mean and the standard deviations. What we found is that concentric contractions did in fact lead to the highest muscle recruitment on average for both the wrist flexors and the wrist extensors. For wrist flexors, the eccentric contraction led to the lowest muscle recruitment on average, and for wrist extensors, the isometric contraction led to the lowest muscle recruitment on average. Below is a table that shows these respective values and their standard deviations, and the 2 graphs show the percent MVC for the participants' wrist flexors and extensors during each contraction type. So overall, the concentric contractions led to the greatest percent MVC for both flexors and extensors. This tells us that there was greater muscle recruitment. During concentric contractions, muscles are shortening and they must overcome gravity to perform this action. That is why more muscles are recruited. For eccentric contractions, they were lower than concentric contractions because as the muscle is lengthening, gravity is assisting the participant in flexion or extension, and they do not have to overcome gravity. Overall, our hypothesis was correct, although we expected eccentric to be lower than isometric for percent MVC for wrist extensors. These results could have been found due to various limitations, including issues with EMG electrode placement and the software we used. As PTs, this has clinical relevance. It's important to understand the differences in muscle recruitment contractions so we can prescribe correct exercise for our patients. If they have injuries and we don't want them to be recruiting as much muscle, then we can possibly use eccentric contractions and therefore use eccentric exercise types. Additionally, it gives us insight into muscle quality that we might not be able to have otherwise. Thank you so much for listening.